Hello and welcome to remote learning for Monday, 8/24. Today we will be doing some notes in our ISN. So we will be doing the Earth and space notes, and then there will be an assignment at the end going over time zones, which we will talk about today in our notes. The time zones assignment will be due Wednesday, 8/26. So first we're going to do the Earth and space notes. So go to Canvas. Go to the Interactive Student Notebook module, select Earth and Space Notes, and then open your ISN on Google Slides. Make sure you share your notes with my second email. You shared it with S. Miller before, but now I need you to share it with wmorgan@eacs.k12.in.us. I want to make sure that everyone sends it to this one as well because I'm going to use this one to grade it. So if you haven't sent it to this one, when it comes time for me to grade your ISN and check your ISN, we're going to run into some issues and you're going to have to share it with me again then. So once you have shared your notes, my second email, go ahead and in the table of contents, add Earth and space notes. Once you have done that, add a new slide and follow along with the notes. So Earth and space notes. So we've learned about some basics of geography, some basic terms when it comes to geography. Now we're going to learn more about the geographic features of Earth and Earth as a whole. So make sure that we are in our ISNs and we are adding to our notes. Again, if you haven't already, share your ISN with my second email, wmorgan, MORGAN, @eacs.k12.in.us. You're going to need to do this so that I can grade your ISN later in the school year. It will be important that I have access to this so I can make sure that you guys are staying up to date and correcting any mistakes so that we have good notes so that we can study for quizzes and tests later on in the year. A reminder that you can pause this at any time so that you can write down the definitions. Definitions will be anything in bullet points. So first we're going to talk about Earth and space. So the Earth has an orbit around the sun. So an orbit is the path one object makes as it circles around another. And this we call a revolution. So the revolution is the circular journey around the sun. It's not a perfect circle. It's more oval. It's wider in parts and closer in other parts. But the Earth rotates around the sun. So if this notepad is the sun, the Earth rotates around the sun. The Earth also has an axis, which we talked about last week with the North and South Pole when we were talking about latitude and longitude some. So the axis on our little globe pen that we'll be using for this, the axis is this white point at the tip, which is the north, and then where the pen comes out is the southern pole, and so the line going through the middle is the axis. So the Earth spins and rotates on its axis. The axis of the Earth actually isn't straight up and down like this. It's at an angle of about 23.5 degrees, and so the Earth revolving around the sun and rotating on this axis is why we have seasons. So while one axis is, as it's rotating, while one point is getting more sunlight because of the axis, that is your summer, and then the opposite side will be the winter. So you'll get more sunlight and more direct heat in the summer, and then the opposite side will get more or less sunlight and heat. So while spot right here, like Russia, will be in its summer, the opposite side down here by South America will be in its winter. We also have the equinox and the solstice. So these are days once a year where either the pole or the equator is pointed most directly at the sun and gets most direct sunlight. So the solstice is the point at which days are longest in one hemisphere and shortest in another. So when our Earth on its point or on its tilted axis, when one pole is pointed more directly at the sun, so if this is the sun pointing towards the Earth, while the North Pole is getting most of the sunlight, the South Pole will not. So the North Pole in the Northern Hemisphere will have its solstice, and this is when the day is longest because it's getting more sunlight as it rotates like this. So the day is longer, and on the Southern Pole, the day will be shorter because it's not getting as much sunlight on its rotation. We also have the equinox, which is when the equator, or our imaginary line at 0 degrees latitude in the center of the Earth, that is when it is rotating and the equator is pointed closest to the sun and getting the most direct sunlight. So this is when points at which everywhere on Earth, days and nights are nearly equal in length, because if the sunlight is coming this way, most of the Earth will get a similar amount of sunlight around the whole world. So all of the equator will get a similar amount of sunlight. The North Pole and the South Pole will get similar amounts of sunlight because the sun is coming directly this way rather than this part, and the South Pole won't get as much. Okay, so we talked about how the Earth revolves around the sun, and we talked a tiny bit about how it rotates. So we're going to talk more about that. So a rotation is a complete 360-degree turn. We also know this as a day. So this takes about 24 hours. So one rotation is one day. And we make sense of this by using time zones, because while in America it may be day, on the other side of the world it is night. So while it is day on our side in the United States, it will be night on the opposite side in India. So in order to make sense of this, if we're talking to our friend in India, we use time zones, which we can see if we look at our large map here. So on this map, we can see the center of our map at the very top has a 0. So that is this light green section. So the UK and then the western part of Africa, or our far left part of Africa, are in this light green, and so they will be both at 0. So that means if it is noon in this light green section, moving one to the right in this darker green section, like France or the center of Africa, it is 1 p.m. So moving from 0, one section crossing this red line, one section, it is an hour forward. If we look at this map, we can see that every country or every section of a country will have a different number in it. So looking at China, we can see China has an 8. That means that it is 8 hours ahead of the UK and Western Africa. So if it is noon in England, here in the UK, it will be 8 p.m. in China. So if we go to the east or to the right on our map, we are moving forward an hour or forward 8 hours. And if we move to the west or the left on the map, we are going backwards an hour. So if it is noon in the United Kingdom or in England, in New York, or where we are in the eastern part of the United States, we have a 5, so that means we are 5 hours behind them. So that would be 7. So if I text my friend good morning, and they live in Ireland, which is part of the UK and is our light green section, if I text them good morning when I wake up at 7 a.m., it's actually noon for them. So that can get kind of confusing when we're talking to people overseas, or it even gets confusing in the United States. So if we look at this map of the United States is made up of 4 different time zones. So we have the Eastern time zone in the red, Central in the yellow, Mountain in the green, and Pacific in the orange. So when it is, let's say it's noon in New York, if we go and see what time it is in Chicago and Illinois, it is actually 11, and then Denver, Colorado, it will be 10, and in Los Angeles, California, it will be 9 a.m. And not all states belong to one time zone. So we can see that there are a few. Idaho is in both Mountain and Pacific, and Indiana, where we are, is both Central and Eastern. So we are in Eastern, but places closer to Chicago in the Northwest and in the South by Louisville follows Central Time, because those two major cities, a lot of the counties and a lot of the people in those areas are so close that they just follow Chicago time or Louisville time, which would be Central. So while we are getting into school at 7:45, if we have a friend that lives in Munster or Lake Central in the Northwest, then they are still waking up in the morning. It's 6:45 for them, and they don't have to go to school for another hour. But if we get out at 2:55, our friend in the Northwest will still have another hour of school. So that can get kind of confusing if you're talking to your friend who lives in Indiana but lives in a Central Time part of Indiana. So rotation, like we said, complete turn, and then time zone is an area sharing the same time. So we're going to finish up today's lesson by discussing what the Earth is made up of. So we talked about how the Earth moves in space around the sun, and then how it moves on its axis and rotates, but we need to talk about what makes up the inside of the Earth. So there are four main parts. So we have the core, the mantle, the crust, and the atmosphere. So the core is the sphere of very hot metal at the center of the Earth. The mantle is the thick rocky layer around Earth's core. The crust is the thin layer of rocks and minerals that surrounds Earth's mantle. And then the atmosphere is the thick layer of gases or air. We also have landforms, which are shapes and types of land on the Earth. So if we look at our diagram, the green sections on the outside are landforms. And if we look at the diagram, we have our center two bits, so the yellow and the orange are the core. The core can be split up into two different sections: the inner core, which is mostly solid, and the outer core, which is more liquid. These are both made up of iron and nickel, and they are both heavy metals, so they draw closer and gravitate closer towards the center of Earth, and as they leave the mantle, they get hotter and become liquid in the outer core, and then they come closer, and as they get closer to the center in the inner core, they get pulled tighter together, and then they become a solid in the inner core. The mantle is this thick rocky layer in red, which is made up of iron, nickel, and a bunch of other elements. And then we have the crust, and then outside the crust, we have the atmosphere, which is a bunch of different layers and protects us from harmful UV rays. So if we have completed our notes and you have finished writing down all the definitions, you can go ahead and close your ISN. And then if we go to Canvas, we have an assignment. It's 9 questions going over different time zones in the US. So go ahead, find the time zones assignment. And then using what we just learned about the Earth's rotation and time zones, complete the assignment. So on our worksheet, if it is 1 p.m. in Indiana, our time, figure out what time it is in the 9 other American cities. So number 1 is, what time is it in Orlando, Florida? So we need to find where Orlando, Florida would be on our map, and then see what time zone it is, and then using it being 1 p.m. in Indiana, where we are, what time would it be in Orlando, Florida? So Orlando, Florida is in the southern tip of Florida, which we can see is also in the Eastern time zone. So if it is 1 p.m. here, it is also 1 p.m. there. Once you have finished all 9, or 8, because I just did number 1 for you, once you've finished all 8, make sure you submit it to Canvas, and then we are done for the day. Okay, I will see you guys tomorrow. Like always, I will be in the Zoom chat to answer any questions. Reminder that Thursday, the 27th, will be an e-learning day, so I will post a small, like 9-minute video talking about what we need to cover for the day, and then there will be a small worksheet assignment that you can complete on your free time or on your own time at some point throughout the day. If you have any questions, let me know. You can shoot me an email at either of the two emails, or ask a question on the Zoom chat or through Canvas message.